for the introduction. So my name is Richard Gentsev. I work for CETECOM. CETECOM is a third-party wireless testing laboratory. We help customers basically get their product to the market, specifically from a wireless point of view. So we work with the FCC and CE as well as the customer to help the customer get through that process. So my presentation today is wireless product compliance, market entry requirements, a necessary evil. So my biography is I've been in this testing space for almost 15 years now. I have worked at Elliott Labs, Intertech, UL, Decra, and now CETECOM. For the most part, it was all related with wireless and either in a sales role or some type of project management role. So here is an agenda, why is this worthy of a presentation? What is a third party, what we can do and what we cannot do. We'll go into the details of what does my product require. From there, we'll do a breakdown of each service, the documentation needed, global market access, and some war stories of kind of why I'm doing this presentation. So just to start off, why is this worthy of a presentation? Well, I want to help you as the manufacturer understand that there are potential significant delays that you can avoid by just doing some due diligence ahead of time. So that is really the point of this presentation. So who is this presentation made for? So it's really compliance engineers and any startups who will be manufacturing a wireless product and maybe who have never, have gone through certification before, what they should be anticipating. So here we go. So what is it a third-party test lab can do? So what we can do is, so keep in mind, every laboratory kind of has their own strengths and weaknesses. Some are small, some are large. CETECOM is around 50-55 people, and our core strength is wireless. So when you go to a lab, you may want to see what their core strengths are in advance. So now, with that being said, what we can do, we can help you provide the standards necessary for FCC and RED. So FCC is the Federal Communications Commission, and RED is basically, it's called the Radio Equipment Directive for Europe. So this will help you understand, okay, what is it that I'm going to need to do to get into compliance? So once we give you the standards, you can basically go online, either purchase the standards or find the standards online, and then you can have access to those standards, and they'll give you the limits as well as how we're testing the product. So another thing that we can do is pre-testing. So in any, if you have prototypes, well in advance of the final production, we can do EMC, we can do RF and electrical safety. So part of the electrical safety is we could do what's called a preliminary design review, and we just review all your documentation and we can provide a non-conformance report. So this will give you time to go back and identify, what the non-conformance are and help, fix those issues. So when you are ready to submit for final testing, you already have gone through the most challenging part. So what we also, obviously laboratory does is full testing. So that is when your product is basically ready to, to be sold on the market. Without the necessary documentation and the reports, you cannot, you're not authorized to sell, whether it's in the US or Canada or Europe. So another thing we can do is provide the documentation checklist well in advance of when your project starts. So we can also do training on how to interpret safety and EMC standards done on a time and material basis. So if you are running into issues with safety or EMC, there's potentially an opportunity where we can help the customer understand some of those issues. So before, a project is started, we typically always help the customer understand what the lead times are, the sample requirements. So now typically after the US, Canada, and Europe, some customers will decide to sell overseas, and we can provide a roadmap for each country. So what a roadmap really is, we provide the sample, how many samples are needed, what the process is based on, the approximate cost, and the process. Some countries require in-country testing, and some countries require just paperwork. So we will provide that as well. So now, really, one of the most key ingredients here is the test mode. So the laboratory as a responsibility, will help you as the manufacturer understand what test modes are required for your testing. So this is regarding firmware and software to run your testing. It is different than, as you would be selling it to your customers. So this right here is very important. So provide KDBs. There could be as many as 5 or 7 KDBs related to a product that has multiple technologies. So we, as a laboratory, will provide you the KDBs. So what is a KDB? It's a knowledge database that the FCC basically has provided some guidance on a particular standard, and there may be more than one for your product. And we would basically find out which ones are relevant to your product. So what is it a lab cannot do? We cannot do design guidance. If the product fails, we can't necessarily tell you how to fix the problem. We can certainly identify the problem. We cannot install or create the test commands for your device. Typically, we would help you do that in advance, as in we would explain it to you. We can't fill out any paperwork for you. We can help you, but we can't sign it, right? So one thing here, this is very important. We cannot assume a product would pass based on an engineering assessment. We can't determine a worst case mode without doing pre-testing. So this is very common. There may be 1 or 2 variants, and a variant may be considered as the heavily populated one. And what happens if you depopulate it? Well, how is the laboratory would determine a worst case without doing some pre-testing to determine the worst case? So many customers think, well, this is the most populated one. This typically or should be the worst case. And in reality, we don't know. So we always want to rely on test data. So here I'm trying to cover a few different requirements. So some of the requirements that we see all the time are consumer and wireless devices, enterprise devices, industrial IoT, and telematic automotive devices. So as part of the laboratory service, we help do consulting up front. So this really basically identifies the standards, the lead times, the samples. In step 2, you would basically go through the testing. And if there's any certification involved, this would be the step 3. So this right here is specific to FCC for a consumer device. So what are the tests that are required for an EMC, for a typical, let's say a Bluetooth device, right? So all devices, whether it's Wi-Fi or Bluetooth or cellular, will have to go through EMC FCC subpart 15B. That's typically a day and can be done relatively quickly. So now, for example, each technology has its own standard. So I just use Bluetooth. So Bluetooth has been around for 10 years or more. So these are the standards here. So we would basically, in our quotes or in the test plan, we would reference these standards. So now if there's multiple technologies, there's multiple standards and multiple test cases. So KDB 993-669 is a KDB that's used for when a product is integrating a pre-certified module. You have to do what's called like a radiated spray emissions test to verify whether the limits have met when the module is integrated into your final product. So electrical safety is not a requirement for FCC approval. NRT approval, NRTL stands for National Recognized Testing Laboratory. This is for the US and Canada markets, and it does not apply to the European Union. So people probably are familiar with this. It's a UL or TUV or a Intertech mark. So that right there is a marketing requirement or a specific requirement from a customer. Maybe like a Home Depot may require to see a UL mark, or even an inspector in a particular county will require to see a UL mark. However, it is not required for you to have a UL mark to get an FCC approval. That those are two separate different things. So now, what is SAR, right? People may ask, well, what is SAR? So SAR is applicable to a device that is handheld, body worn, and the antenna comes within 20 centimeters to the body. So think tablets, laptops, cell phones. This is an additional requirement above and beyond RF and EMC. This is a regulatory requirement. It's part of the FCC. So the FCC certification is required when a radio module is not certified or if the conditions of the radio module are not met. So I'll go into that a little bit later. So typically, to get all this stuff done, it could be anywhere between 2 and 4 weeks, and another 1 to 2 weeks for certification if needed. If SAR is required, this could be an additional week or two or more. It really depends on the type of technologies you're using. The more technologies you use, the more SAR testing will be required. So just for example, we would typically need around 2 samples to complete this type of testing. So now, as a manufacturer, you may say, well, hasn't someone done this before? Can I just see what another customer has done? And you can piggyback those results. And the answer is yes. So this right here gives me the opportunity to show you this. Can you guys see the screen?
It is not switched over yet.
Okay. I see. So hold on. Now?
Yes.
Okay, perfect. So this is the FCC website. This is a free and public website. Anyone has access to it. I think everybody knows who Apple is. So you can run a search by the applicant name. You can run a search by the dates. So I just chose a couple of years just to show, what's been going on with Apple. So you run a search, you can show 100 records at a time, and you hit start search. So keep in mind that all this is public. So you are able to see the grant, you're able to see the name of the person who's responsible for this, but really you're able to see the reports. So the reports are really what you need to see as a manufacturer. So you can look at the internal photos, you can look at many, many different things. So really you can spend all day looking at these things, but I'm not going to go into too much detail. I'm just going to show you one report. So this is a smartphone. Here's your report, and you can go into the details. You know, here's all the details what they did, the testing laboratory did on a smartphone. So if you're a manufacturer and you're just, you're making a smartphone or you're making some type of Bluetooth device, you can search on the FCC public website, and you can pull the reports, and you can pull a lot of information. So now I will switch back and go back to my presentation here. Okay, can everybody see this now?
Yes, it's back up.
Okay. So typically, this is the documentation needed for FCC. So you, as part of what I just showed you guys, this is the information that will be held public when you do an FCC approval. So typically you have internal photos of the EUT, which you saw, block diagrams, schematics, circuit diagrams, parts list of all the components, tune-up information, antenna specifications, user manual, and power of attorneys, as well as operational description of the antennas. And there could be more paperwork, but this should be the majority of the paperwork that you need. So let me go now to RED. So RED is a radio equipment directive. It applies for wireless products, and CE is basically European conformity. You will have to, as a manufacturer, will have to show compliance to these directives. So CE requires all applicable directives for you to meet or show compliance to. Typically for a consumer device, you will have the EMC directive, a low voltage directive, and the RED directive. So the RED directive is all wireless testing. If you have Bluetooth or Wi-Fi, you have to go through a very similar process, how FCC applies, but there are different standards for Europe, different limits for Europe. So there isn't a database like there is one for the FCC. It is self-declaration process typically. So once you have all your reports, you create a self-declaration of conformity and you list the directives and you sign it. And at that point, you can list your product with the CE mark. So look, there is one difference here. It is safety. Safety is a requirement, not like in the FCC or the US. It is not a requirement. So here it is. You have to show compliance to the low voltage directive, which means electrical safety. So that is a key difference from the US and Europe. So that's what I think I'm bringing up here. So there is a TCB, a technical certification body for FCC, and for Europe, it's called the notified body. So a notified body may be required when your product is using a non-harmonized standard, and it will be a requirement. Or some customers will hire a notified body just for an extra set of eyes or due diligence as part of their safety and quality process. So just to give a lead time, it could be anywhere between 4 and 6 weeks at a typical laboratory. Samples, you may need 2 for safety, 1 for EMC, and then for RF, you're going to need 2 conducted and 2 radiated, and all the additional paperwork. So here are some other industry related certifications. These are not regulatory. These are strictly industry. So there's PTCRB, Bluetooth SIG, Wi-Fi Alliance, LoRa Alliance, Qi, and Thread. Bluetooth SIG is anytime you're wanting to put the Bluetooth logo on there, you'd have to show some interoperability testing. Wi-Fi Alliance is very similar. You have to do some interoperability testing. LoRa, same thing. Qi, again, same thing. If you're trying to use the logo, you have to go through a wireless power consortium lab. Thread, I'm not so familiar with Thread. I assume it's very similar. It's some type of interoperability.
Richard, you had a question about PTCRB. Can you expand on that a little bit more?
Yeah. I was going to cover that right now. So,
Oh, sorry.
Yeah, no problem. So PTCRB is strictly related to cellular devices. So if you're integrating a, let's say you're integrating a radio module that has cellular technologies, there is a consortium of about maybe 10 carriers or so, and they would require to see some performance testing. So typically you have to do over-the-air testing. If the antennas are internal to the device, that may be a requirement. There's radiated spurious emissions. So as the laboratory, we would identify, first we would ask, well, what is the FCC ID of the radio module? We first then identify the number of bands supported. From there, we would identify the scope of work. So in each case, it may be very similar. We would identify if there's any actual SIM slots. We would identify if there's OTA testing needed and radiated spurious emissions. And then there is some project management involved. There could be, if the module supports VO, voice over LTE, there may be a simple test to verify or disable that. So it is quite a lengthy process for PTCRB, but this right here is strictly the integration of a pre-certified module. So we're not talking about the full-blown PTCRB testing when on a radio module itself that didn't go through the testing. That is something that we don't do, and that is something that I'm not covering in this presentation. So does that answer your question? So this falls more on the PTCRB side. So T-Mobile's, Verizon's, AT&T, they all follow PTCRB. Verizon does have their own specific test plans and may require additional testing than say an AT&T. So as I mentioned before, we have to do radiated spurious emissions over the air testing and helping you go through the process of walking you on board, basically onboarding you to the PTCRB network and PTCRB website. So as customers decide to launch products overseas, they may ask, well, what are the requirements, right? So there is something, as a laboratory, we can help you identify all the key ingredients to sell your product into a host of almost 200 different countries. So a lot of customers will ask me and say, okay, well, what's the labeling? Where does the labeling go? What's the labeling? What language does it need to be? How does it go, right? So all those things are crucial to launching your product, right? So let me show you guys something. Oh, can you guys see this screen now? Don't like going back and forth all the time.
No, we're still on the global access, market access screen.
Okay. How about now?
Yes. Anatel?
Yeah, perfect. So CETECOM has created a database, probably, I don't know, maybe at least 5 or 6 years in the process. So this is a tool to help the customer understand exactly what the labels are. This is a project management tool as well. So just to show my point, we have the label information for every single country. So Anatel is covering Brazil. So you can go in here and see, okay, is there e-labeling? What's the minimum size? Here's the logo, here's the restricted documents. Well, I wanted to show you one more. So this gives you the link to the actual regulatory body, even though it's in Portuguese, we all have that there. And we also have the native documents. So the native document is what we're following to obtain the certification. So that's really important as well. So we as a laboratory will help you understand the sample requirements, what it's based on. Brazil, for example, will require you to send samples in the laboratory, and there's a little bit more cost involved, and there's a little bit more risk involved because you have to have someone kind of manage that process. So a laboratory can help you do all those things. Give me 1 second. So just to give you a little bit more information about that tool. So it gives you the country view. So it gives you all the information based on the different countries and regions, the frequency view. So what frequencies are allowed and what are not allowed and the parameters of each country. The approval requirements. So all relevant information on approval schemes like the native documents, and then all the detailed information on product labels. So that will be all included when you're working with a laboratory. So this kind of gets me to kind of almost the end of my presentation. So in my 14 years, what have I seen? Some war stories. So I just want to give you guys an idea of what some customers are doing, or what they've faced, right? So here's an example: silicon manufacturer. They're
Hey, Richard, you went silent. We've lost audio. We're still not hearing you, Richard. Richard, can you hear?
Richard, can you hear us? Can you hear me? Yeah, we seem to have totally lost contact with him there somehow or another.
Yeah, I'm not sure how to. Let me see if I can text him. I don't know if he'll pick it up. Richard, can you hear me?
All right, we'll wait for Richard to log back in and come back up. Not sure what happened there.
That was interesting.
While he's offline, can y'all introduce yourselves?
Yes. Hi, Greg. I'm Ed Bray. I'm with AEM Group. We are the manufacturer's representative locally for CETECOM. And I'll make sure that I put my contact information in the chat. at the end, if you all have questions or would like a further conversation on this subject, then definitely reach out to me and we'll set that up.
So who else do we have?
I'm Chip McClellan from CN Sites. We design, build, and ship out industrial IoT sensors primarily for parks and recreation spaces to track visitation and environmental stuff.
So Chip, do you do your own RF engineering work, or you just use other people's modules?
I use other people's modules. So I rely on the certifications and PTCRB certs for the particle platform. And then, the hardware that I design, basically the carriers, I do a unintentional radiator self-certification.
Okay, so then we have, let's see, I guess Ron. We haven't heard from.
Hi, I'm Ron Coleman. I serve as a consultant for product manufacturers, helping them achieve their regulatory obligations. And so when it comes to FCC and RED compliance, we work with CETECOM and some other wireless labs to apply the correct product standards and SAR and do all the testing that they need to put their product on the market.
Okay, so then let's see here. So we've got, I think the last one that hasn't said anything. So I'm Greg Warrens. You can see I have a new wireless modulation technology I'm trying to get devices built for. If you happen to know any RF engineers who want to spend a Saturday playing with me getting a device working, please let me know.
Will do. Thanks, Greg. I think he's still having trouble.
Yeah, it looks like it has. Did he get your text to respond to you at all, Ed?
Yeah, he came back in and he still isn't able to hear us. So I think he's rebooting.
Okay.
Shouldn't be, but just another minute.
Okay. Yeah, we've got about 20 minutes left in the time slot, so we'll see if he can get it up and running again.
Okay. In the meantime, I'll put my my contact information in the chat, and you guys, if you have any more questions or want further discussion, then you know how to reach me.
Cool. Thanks, Ed.
Sure.
Chip, can you also post your contact information? I think I have a partner that might like to connect with you.
Yeah, sure. Yeah, I'd love to. Also, I'm actually working on a new thing now that could be open up another bag of worms. It's what they call a LoRa gateway. So cellular on one end, LoRa on the other, and a lot of places, the parks that I put stuff in they don't have cellular coverage because they're parks, and so having to be able to bridge from the LoRa to the cellular has turned out to be a big thing. So I'm working on that too.
Yeah, it has. I would have interest in that as well. We've got a design that we're supporting that is actually two designs that are doing that, and we're but we need to it's multiple LoRa radios feeding into a gateway and
Right.
like a router configuration.
Yep.
So
That's actually what I'm doing. So each of these gateways can serve, let's say, a dozen or more nodes, and the big thing that's making it hard for me is most gateways are powered. So they're always on, which makes it really easy because then you can optimize your nodes to just wake up, send a transmission, go right back to sleep, save the batteries. But all of my devices, including the gateway, have to sleep because I work in parks where there's no outlets and there's no Wi-Fi. So and in this case, in some places, no cellular either. So it's a sleepy gateway, which has been a bit of a challenge. We're getting there.
So you're having it, having the gateway wake on access from LoRa and monitor the cellular for connections, or?
It actually, what it does is it wakes and goes into listening mode. The nodes wake and report, they get their clock set, and then they get a window assigned for when they're supposed to wake and next report. So then they go back to sleep. The gateway collects all the nodes inputs, packages them up into a queue, connects to the cellular network, and publishes that queue via webhooks.
So is it essentially one directional from the nodes to the gate? Well, between the nodes and the gateway talk to each other, but does the cellular uplink is basically just pushing data up to the cloud and not rather than receiving?
No, it's actually both. So now if you wanted to change the configuration of a node, let's say change the opening hours or change the way it serves as a sensor, you would push that to the gateway, and the gateway would then update the node on the next exchange.
So what frequency ranges does LoRa use? I'm not familiar with the specification.
There's two bands in the US, but I'm using the ISM band at 915 kilohertz.
Megahertz.
Megahertz, sorry.
Hello, everybody. Can everybody hear me?
Hello again.
Hey, welcome back.
I was in the matrix, so I'm back. So sorry about that. I don't know where exactly I left off. I know it was a while. So
Right as you started the war stories.
okay, perfect. So let's go with the war stories. Oh. So the very first one I was talking about was a Silicon Valley manufacturer. They were teaming up with a high-end jewelry maker, and they wanted to make put in a wireless transmitter with some high-end fashion. So at the time, there wasn't anything being done or made prior.
Richard,
Yes.
are you speaking to your presentation? Because we're not seeing it.
Okay. You may want to, can you give me, okay, you gave me the option. Sorry about that.
There we
Okay.
go.
All right, perfect. So this was a new and unusual product because it was, jewelry with a transmitter. So there wasn't a process established by the FCC at that time. So what ended up happening was we ended up doing some SAR measurements, and we would submit that to the FCC and see whether or not they would use that as substantial evidence to grant the authorization. They kept saying no and no and no. So what normally for a product that is similar to this, or at least similar, is a couple of weeks of testing. We ended up doing 2 months of testing and it was extremely difficult. So this was a war story that the customer just, it was very frustrating for the customer. But the reason was, again, is because there was no actual, standard to show or limits to show exactly what needed to be done. So this is kind of an unusual one, but again, if you're a new company and you're making a new product and there isn't many requirements out there, you may come across this problem and it could be a showstopper, right? So a Qi charging manufacturer, these guys here, they ended up switching components. The original certification was done with a different set of components. They had to recertify to add this new component, right? So you have to think as a manufacturer, if I change the hardware, more often than not, I have to show some compliance to it. And the Qi charging is also a new technology. And when we did the original certification, there was no FCC certification, meaning the product did not have to go to the FCC for the FCC to issue the final grant, right? So when we did the recertification, a standard changed. And this required now the product to be sent to the FCC. The FCC is a government, entity, and they work different than testing laboratory. They take longer to issue things. So now the testing laboratory, it's out of our hands. It's strictly in the FCC's hands at this time. So now again, lesson 2, things change all the time, and even in recertification, know the standards, know the requirements, so you can avoid or plan accordingly. Because of this, the vehicle, manufacturer, we're potentially are going to be held the line up because of this product wasn't being installed. So that's, very, very big problem. So now Amazon is requiring, ISED certification on wireless devices. This wasn't a requirement last year. This was sent sometimes earlier this year. So if you're a distributor and you don't have any ISED certification on it, Amazon will not let you sell that product on their website. Another story, war story is, we got the customer in the laboratory, they're ready to start testing, but then we tell them, look, we need particular firmware and software commands. They don't know how to do it. They need the support from the customer in Asia, and it wasn't a reputable company. It was a very small mom and pop shop, and they could not get the support, and they could not, complete the testing, right? So it's really important to know where your components are, especially the cellular module, the radio module. That's one of the key ingredients in your product. And this is, one way you can avoid failing. So what can cause a delay or a non-compliance? So incomplete paperwork. A TCB will not even start a review without all the paperwork. Same thing, incomplete testing. You may use multiple labs. You may use one lab to do SAR. You may use another lab to do electrical safety, and there may be something missing. Okay, so if you
Richard,
yes, sir.
we got a question. I'm gonna go ahead and just start calling out the questions because we're running out of time. But ISED, can you expand on that a little bit?
Absolutely. There is the FCC, Federal Communications Commission, and the ISED is basically like an entity in Canada. It's the equivalent of FCC. So if you have FCC, the laboratory typically can use the FCC certification results and apply the ISED and obtain it's what's called a certificate. But it has to be within 1 year of issuance. If you don't have any compliance whatsoever, FCC, you would have to start from scratch, and that would be a considerable cost, especially if you're only selling 1 or 2 devices. It may be, too much money for you to sell your products now because you're only selling 1 or 2, and the certification may cost 10 grand, right? So this right here, I really think this is my last slide. Yeah, so this is my last slide. So, as I mentioned earlier, not having the support from overseas, or if you don't have the experience to run the firmware and software, if you don't have enough samples to do the testing, if there's a failure or damage, that will end up halting the testing. If your product falls under a PAG, a pre-approval guidance, like the very first product, a jewelry product, we will need to hear from the FCC before we can start testing until they give us a clear path to move forward. So this right here is my conclusion slide. I do apologize for the technical difficulties there. We still have around 9 minutes. Hopefully we can cover any of the remaining questions.
Just open it up. I think mainly Gregory had most of the questions Did, was, Gregory, was he able to answer those as he went along, or did you want to go back to some of those?
So, well, one of the questions I asked early on was the difference in certification requirements if you're using a proprietary communications protocol in a point-to-point context relative to using one of the existing standards.
So if it's like a Zigbee, or if it's a protocol that is, it could be, we would have to apply a standard, maybe 247, that's similar to that frequency range. So we would look at the frequency range, and we would apply the most applicable standard for, you know, like a Zigbee is kind of a self-proprietary technology. Will be operating on a certain frequency, and again, we would look at the frequency and then determine what would be the most applicable standard for that. So we've seen many different types of technologies that are not, you know, pre-certified or you know, proprietary. So does that answer your question?
Yeah, so I'm looking at building devices that use the 915 megahertz ISM band, or the 2.4 gigahertz band, using a proprietary modulation. So
Okay, so that would probably be 15.247 probably would be the most applicable standard, but I can certainly check with our team and get back to you.
And then you alluded to it, but didn't have an address explicitly. So what are the sort of order of magnitude scale the certification going through this process costs for just doing basically United States, Canada, North America, and Europe for this kind of device?
Well, for 900, well,
We're talking 100,000. What sort of? I'm just trying to get a sense of the
yeah. I mean, in general, the more technology you have, the more cost will be associated for it. But for one technology, like let's say like a LoRa technology, you have to do RF and EMC, and you may have to do certification. So let's budget around 10 to 12,000 and maybe 4 to 5 weeks to do something like that, right? So that's unlicensed technology, like what you're getting into. So that's kind of what. So you have EMC, the FCC subpart 15B. If it's 15.247, that is the RF portion. And depending on all the modulations you have and everything, and it may be, you know, it may be a hybrid, or we would understand the details of your product. And then there's the certification side of it. So that's a rough, you know, very good ballpark, between 10 and maybe 14K, something like that.
All right. That's less than I was expecting.
Good. So any other questions, anybody?
Yeah. Hey, Chip here. I don't know if it was answered, but I did ask a question in the chat about the unintentional radiator kind of assertion or a sort of self-certification, I guess you'd say. How do you see that used? You know, specifically with you know, boards that build around pre-certified modules that have the FCC certs.
So for the unintentional radiator side, that would be conducted in radiated emissions. So typically you would have to do radiated emissions from 30 megahertz to 1,000 megahertz, and then you have to do conducted emissions. So you're manufacturing the board, or because if you're integrating, the final end product will have to go through unintentional emissions. That's a FCC requirement, regardless of if there's you know, Wi-Fi or Bluetooth, any type of wireless. We're shutting off the wireless and we're just putting it in idle, and we're just exercising all the ports, all the digital circuitry in there, and we're doing those two tests, right? That's a requirement, unintentional emissions. Intentional is when now you are actually transmitting, you're sending a signal. Maybe you're using Wi-Fi, maybe you're using Bluetooth. At that point, we have to do some verifications on your product. You're integrating that module, and we have to do some radiated spurious harmonics on that product. There's a whole bunch of other tests as well. I'm not the engineer, but in general, there's quite a few tests that we would do. So just tell me more about your product, and then I hope to maybe clarify.
Yeah, so it's basically a I mean, the core of it kind of looks like this. It's got a cellular module, right, which is FCC certification, PTCRB, that I purchase. It's got a LoRa module that again is in the CAN and also has an FCC cert. And what I designed is the carrier board, which helps it exist in outdoor environments, manage power, memory, things like that, but nothing on there that should emit radiation. And then obviously the firmware that comes together and makes this whole thing kind of work. So my hope is that, by taking advantage of pre-certified modules, I can reduce the cost and the complexity of getting the system certified.
So that's the idea. So you want to look at the types and gains of the antenna. You don't want to, when you have the FCC ID, there will be listed on there the gains, the types, and so you cannot exceed the gain.
This antenna is part of this module cert.
Okay. Okay, so with that being said, you're going to leverage all of the conducted. So you have two types of tests. You have radiated and you have conducted. So when you are using a pre-certified module, you're basically leveraging all of the conducted tests, right? All now we're doing is, if you have a cell modem or module and it's operating, let's say, in 5 different bands, North American bands, right? Band 2, band 3, band 5.
Band 12.
Yeah, all right. So we now would do a radiated spurious emissions check to integrate now that your final end product integrating this radio module is meeting the limits.
Okay.
Right? That you understand?
Yep.
If you are not using a pre-certified module, you would have to do testing on the actual radio module, right? And that's radiated and conducted, and the testing would be much, much, much more expensive. So we're only doing like a portion of the testing. Conducted is like 25%. So you're taking out 25-30% in some cases. So so that's the benefit.
Oh, well, that is kind of why I chose these modules too, right? So yeah, good to hear that. Thank you.
Okay. Well, I think we're right at 2. And again, I think, I ended up, spilling over there with some audio details and information issues. So, but at any rate, we made it on time.
Very good. Thank you, Richard. Again, good job with the presentation. Great information. Thank you all for your participation as well. And if you would like to get in contact with Richard or Ed, please feel free to contact them. I believe Ed put his information in the chat room, and you've got Richard's information there. And if we can be of any help in any way, please let us know. If not, enjoy the rest of your Wednesday. Thank you all.
Thank you.
Thank you so much.
Thanks, Chip. Bye.
Thank you very much.
Thanks, Richard.
Thank you.